Good morning, good afternoon, good evening, whatever and wherever you are. My name is Anna Rochelle, and today we are going to finally finish this chapter 3.1 to 3.4 review. This is the last video of 3 videos. This is, in fact, it was a separate worksheet altogether. It just had 12 graphs, and the instructions were the same for each one of the problems. It said that we needed to state the domain and range. We needed to tell whether the graph was a function or not. And we also needed to tell whether the graph was continuous, discrete, or neither. So without further ado, let's go ahead and let's talk about these. I may or may not write all of the domains, ranges, and I may not write all of the information, but I will definitely say it. So if you are one of those kiddos who just likes to fast forward to see the answer, this is not the video for you. So definitely make sure that you're paying attention. If you really want, you can listen to me in double speed. That's totally fine. That way you can at least understand and see what all the answers are. Okay, so let's get right to it. In this first function, in this first graph, we know 100% that this is not a function. It is not a function because it does not pass the vertical line test. So we went in video 2 or 1, and I will definitely link the videos together so that you can see them together. I know that this is not a function because it does not pass the vertical line test. And we can state that the domain is just -3 because every single value on this graph is going to be -3 for the x and 2 for the x. So my domain would just be -3 and 2. And then my range in this case will be all real numbers because I know that I'm going to go from way down there in the depths of despair of -infinity to all the way up to positive infinity because I have arrows that are pointing in opposite directions. And the other piece that I know is that they're both kind of at y equals 2. So that y equals 2 is going to be another option for my domain, for my range. Okay. Since it's not a function, I'm not going to tell whether it's continuous or discrete. The next question we have here, and I didn't put any of the tick marks, but I did put in the important information. So in here, I need to know that I start off at -5 on my x value, and I end off at +5 on my x value. So my domain is going to be between, actually, let's not put the or equal to, between -5 and 5. And I know that it won't be or equal to here because it's an open circle, and we know that open circles always have just less than or greater than symbols. And this is a closed circle, so this will be or equal to because it is a closed circle because that is an actual option for my range, for my domain. Sorry, I was thinking about range right away. And so in my mind, I said what I was thinking. The other piece that we know is important is we want to know the upper level and the lower level of my y values. And so I just needed an upper value here because my lower value for both of these happens to be -2. So I'm going to go -2 is less than y, which is less than or equal to 2. Actually, I'm going to put both or equal to because it does actually hit at -2 on the right-hand side point. So it includes all of the numbers in between those domains and ranges. I do talk a little bit more about this, I think, in my first or second video. Again, I'm going to link all of that in the description so that you have access to that. This is a function because it does pass my vertical line test. And this is what we would call a continuous function because I know that I can potentially have a point of 0.00000000000000001, comma 1.9999999, right? So I can have almost close to 0 on the x and almost close to 2 on the y, but not quite right there, just a little bit lower, right? Or a little bit higher or whatever. So this is going to be a continuous function. Okay. This for sure is a continuous function because it starts off way in the depths of despair of negative infinity, goes all the way up to the top of positive infinity. So this is 1,000% a function. It is continuous. And the way that we know it's a function is because it does pass that vertical line test, right? And so my domain and my range for both of these happen to be all real numbers. Now, I've seen it written like this. I've also seen it written like this. I've also seen it go from negative infinity to positive infinity with the negative and positive sign as well. So I've seen all of these possible options, and it just depends on what your teacher does, what you guys are used to in your classroom. I don't think that there should be any offense taken to either, or it's just what does your teacher do? Okay. Let's talk about in this case. In this case, this is also a function because it also passes the vertical line test. It is also a continuous function. And then let's talk about the domain and range. So here, I know that my domain extends all the way to negative and positive infinity. So my domain is all real numbers. I'm used to writing this fancy pants R also because my last name is Rochelle. You know. And then my range, I am going to just say that y only equals 3. So again, if this is not how you write your range, if you write it like this or some other way, definitely make sure that you're including every single number in the way that you're saying that the domain is. Okay. In here, I tried to make all the tick marks just to give you an example of what the graph actually looks like so that you know, so that you're not like, this is not the same as my actual review sheet, Miss Anna, right? So I'm going to go in here and I'm going to state all of my values for the X value for the domain. So I see that I have a point on this X value, on this X value, on this X value, on this one, and on this one. So I know I'm going to have -3, -2, 1, 2, 3, 4, and then 5. That's the way I figure out what my domain is. My range, I'm going to do the same exact thing. I know I have a value here. I know I have a value here, here, and here. So then I know that this is -1, 2, 3, 4, 5, -5, 0, 1, 2, 3, 4. And that's how I have my my range and my domain. One of the things that we want to notice is that the domain X values never repeat. So we know that also our graph passes the vertical line test. So yes, it is a function, but in this case, it is a discrete function. And it is discrete because I have specific points. It's only possible to be here. It's only possible to be here, right? Versus continuous, it's like very loosey-goosey. It continues forever. It could be all these decimals. And this graph is saying, no, if you are at -2, you are at 0. You cannot be at -1 and 0, -3 and 0. This is the only place where you can have a range of 0 and a domain of -2. That's it. Nothing to the left, nothing to the right. Everything is very discrete. Everything is very specific. So discrete meaning not in the usual sense of discrete, like, oh, I'm kind of discrete, I'm secretive. No, discrete as in like, I'm very specific. This is what I have. This is it. And there's no loosey-goosey anything happening here. Okay, so again, let's take a look at problem 6. This is definitely a function because it definitely passes the vertical line test, right? My vertical line does not hit anywhere left or right in 2 spaces or more. I do know that this number is an important number. I know that this is on the x-axis. So my domain is actually going to be everything where x is less than or equal to 4. Because anything that's greater than 4, my graph doesn't show up there. My graph only shows up on these values, right? And my y values are only positive, right? So again, you can say that y is greater than or equal to 0. You can say that y is all positive real numbers. Those are also options. And this is because this is a function and because I don't have specific discrete points here and there, because it's like a ever-going line with an arrow, we know that this function is a continuous function. Now, in this particular case, on the graph, it actually shows a circle, but clearly I am not capable of drawing a circle with my specific parameters. I know that I have a y value here and here, and I have an x value of here and here. So what I'm doing is I'm marking off my domain, my domain and range. Oh gosh, I can't write anymore. My domain and range pieces of information. So I know that my domain is all of my x values. I know my range is all of my y values. And I know my x values go from -2 to +2. So I'm going to hit -2 to +2. And I know that my y values go from 1 to 4. So I'm going to hit 1 to 4 on the y values as well. Again, all you're doing is just counting the spaces left, right, up, down to see that. And because this is not a function, I'm not going to go ahead and I'm not going to say it's discrete or continuous. That's just not a thing. This W function is going to be a lot more popular when you go into Algebra 2. You're actually going to be graphing functions like this from scratch. You don't quite do that yet in Algebra 1, but I just want you to like keep that in the back of your mind, like, hey, this is going to be important again later on in life. It is a function and it is continuous because it does pass that vertical line test. And then we know that the domain is going to be all real numbers because I'm going to continue to go all the way to -infinity, continue to go all the way to positive infinity. Excuse me, positive infinity. So it's all real numbers. And then my range is going to be everything greater than 0. So my y is going to be greater than or equal to 0. And in this case, it's going to be greater than or equal to because it actually does touch here and here, okay? So because it does touch in both of those places, I want to make sure that I label that appropriately. Okay, so this is one of those fun functions that is actually not a function at all. Problem 9 does not pass the vertical line test. You can see in multiple places it hits at 2 points. But we do want to make sure that we label the domain and range appropriately. So one of the things that I want to say is, hey, here's my upper limit, my lower limit for the range, right? Oh, no, that's weird. Okay, not sure why that didn't show up. So because I started with my y values, we're going to start talking about the range first. So my range, we know, is always my y value. We also know that I have an open circle here and an open circle here. And because they're both open circles, we know that it's just going to be both less than symbols instead of the less than or equal to symbol. I also know that I can count up high and down low. So this will be -1, -2, -3, -4, -5. So my range will go from as low as -5 to as high as 1, 2, 3, 4, 5. And that's how I determine my range. Now, my domain, I have, change that color. And my domain is all of my x values, right? Whoops, I think we're going to need to move that. There we go. Okay. So my domain is all of my x values. So I'm going to start off by saying x in the center. And I know that only on this right-hand side is my open circle, right? So I'm going to have a just less than symbol versus less than or equal to. And because this is not an open circle, because this is a closed circle, I'm going to have less than or equal to here. And again, I'm going to do the same exact thing. I'm going to count -1, -2, -3, -4, all the way on the left-hand side, and 1, 2, 3, all the way on the right-hand side. And that's where my domain and range are for this non-function function, right? Okay. Again, I think that at this point we have 3 more problems left. I would recommend even going back and going in and saying, okay, how do I do these problems on my own? Maybe backtrack, try them on your own a different day when you're studying for these quizzes or tests or whatever it is that you're studying for. Go back, try the problems again on your own. You have the answer key in this video, so it's just a matter of going to the right place in the video. And then that should help you practice and practice and practice. And the more you practice and know what you have as a correct answer, I think it'll be super helpful as you prepare for your assessments. Okay, so let's take a look here for my domain and my range. So I know that my domain is going to continue forever in this direction to negative infinity and forever in that direction to positive infinity. So in this case, my domain is all real numbers. It is fancy pants R. It's going to go on forever outwards. My range, on the other hand, while it will go forever on upwards as well as outwards, right? So it'll always hit that positive infinity section. I know that it will not go on forever down. It won't go forever down because I have a cap at this y equals -3 business right here. So I can say that my range is greater than or equal to everything that is -3. This is a function because it does pass the vertical line test, and it is a continuous function because A, I have the arrows, and B, because it just continues in a straight line. There are no breaks, there are no specific discrete dots. Let's take a look at this guy. So this guy, again, the same business. We want to know what the lowest value is and what the highest value is for both my X and my Y. So one of the things that I want to notice and pay attention to is this arrow right here. So this arrow right here tells me that my domain is going to go on forever to positive infinity. Actually, write domain here. And so we're going to go on forever to positive infinity, and it's never going to stop. But my domain does have a stop. It has a stop right here at -5. Because this is an open circle, I'm not going to have an or equal to symbol. It's just going to be the less than symbol. That's it. That's as far as we go. Now, my range, on the other hand, doesn't have a forever into positive infinity. It actually has a forever into negative infinity, because as this goes out to positive infinity on my domain, it's also going to go down forever onto my negative infinity on the range. So I know I'm going to start with negative infinity, which is less than or equal to the y values. And then I'm going to make a less than symbol because I have these open circles here with a y value of 1. So this is my domain, this is my range. All of my open circles mean just less than or greater than symbols. All of my actual points, like in here, for example, this is an actual point. This is an actual point. We are going to do or equal to. This is a function, and this is actually considered a continuous function. The reason why it's considered a continuous function is because there is a line. We are connected, and we can have these fractional pieces of the graphs so that we can go in and say that, 0.00000001, comma 1 is a possible option on this graph. So it is continuous. First of all, looking at this, number 12, not a function at all. Last and final problem, not a function. So discrete continuous does not matter here. And one of the things that I want you to notice is the X values are very specific. They go from -3 to +3. And the Y values are also specific. They go from -2 to +4. So in this case, my domain is from -3 to +3, and my range is from -2 to +4. And again, both of these are going to be or equal to, because all of my dots on the edges of the graph are very specific. They are filled in, they are not open. All right, this was the last problem in my chapter 3.1 to 3.4 review. This is the last of 3 videos. I will see you in other videos. And as always, definitely reach out to me if you need some additional support. Bye.